All right, so we're told that we have a beach that has sand of grain size 1 millimeter. We have a water temperature of 30 degrees Celsius, and we have waves coming in with a period of 10 seconds. And we're asked to find the offshore wave height at which the beach will start eroding instead of accreting. Right, so what this problem is trying to get at is the whole idea of fall time parameter, where h naught over fall velocity times wave period is equal to your fall time parameter, or just FTP. And then if FTP is less than 2.5, your beach undergoes accretion, where the beach builds up. And if the fall time parameter is greater than 2.5, your beach undergoes erosion and is slowly eroding away and no longer becoming a beach. So if we want to find the offshore wave height at which the beach starts eroding, we want to find that transition point where the fall time parameter is equal to 2.5. Right, so we're going to have offshore wave height over fall velocity times period equals 2.5. Therefore, wave height is equal to 2.5 times fall velocity times period. All right, so we were given the period for the waves, so all we need to do is find this fall velocity. So the way we're going to do that is we're going to look at this chart that's given in the lecture notes and on the equation sheet. So that's vaguely what the chart looks like, right? You have a bunch of lines with temperatures on them. Your y-axis is the grain size for the beach in millimeters, and your x-axis is your fall velocity in centimeters per second. So the way you're going to read this is you're going to take your grain size in millimeters, which for us is given as 1 millimeter, and you're just going to read across until you get to the right temperature line. So for us, that was the 30 degrees Celsius line. All right, and then once you get to that, you're going to read down to the fall velocity in centimeters per second. Now, granted, this is a very poor representation of what this graph actually looks like. You need to go look at the actual thing. And if you read off it correctly, you should get a fall velocity of about 18 centimeters per second for a grain size of 1 millimeter and temperatures of 30 degrees Celsius. So now that we have that, we can solve for our wave height is equal to 2.5 times 18 centimeters per second times 10 seconds. And then because centimeters are weird, we don't talk about and think about things in centimeters. I'm going to go ahead and convert 100 centimeters is 1 meter, and we get a wave height of 4.5 feet. Correction, 4.5 meters. All right, so that's the offshore wave height at which the beach starts eroding. Now, the question also asks us, okay, so now that you know that, just try to reason out, do you think that this beach normally erodes or normally accretes? All right. Now, for thinking about it, right, 4.5 meters, 1 meter is 3.3 feet, right? So that's a wave height of 15 feet. So think about the last time you were at the beach, or many, many times before that. How many times did you see 15-foot waves coming into the shore? And not just a 15-foot wave, but continuous 15-foot waves over and over and over again, right? That's not super common, right? So if you need a 15-foot wave in order for this beach to erode, then that's telling you that normally this beach is going to undergo accretion and be building up over time.